So in Visual Studio, I have a solution that I've already pre-populated with some of the information. I'm not going to spend too much time on the ASP.NET application, but as I mentioned, this is hosted on GitHub, and I'll link to it at the end. But what I want to show with the ASP.NET application is how easy Visual Studio makes it to publish it to a live running web app. So here's my API. I'll look at the one class that I've actually modified. Most of this is from the template. But here's my single controller of interest, which has some metadata about my Azure services. These are just keys and other private information. That's all obfuscated from the code through a resource file. Then I have two methods of importance, get, which is just going to get a list of all the documents, and post, which is going to post a new document. So it actually takes in the parameter, my custom event from my portable class library. So this is actually shared code. And then it writes that to the database. And that's pretty much it. So two classes. You can find those online. But
so is keys hard-coded in the code somewhere?
Yes. So keys is in my portable class library in a resources file.
Okay.
And I don't want to show that to everyone because then they can mess with my services.
Sure.
So what I'll go ahead and do is show you how easy it is to publish. So if I right-click on the application itself and I have the web tools installed, all I have to do is find publish right here. I sign in with my credentials, which I've already done, so it should cache it. I can see my profile, so I would select Microsoft Azure App Service.
Yep.
It would populate with all of my services, select the service, OK. And if this was a production environment, I would just hit publish. That's it. But since I want to actually debug this later, I'm going to go ahead and change the settings to make sure it is debug any CPU, which I did that before. So I'll hit publish, and that's it. So now this is actually going to send this code to my live running ASP.NET web application hosted in Azure.
Yep.
So just to test that, as soon as it finishes publishing, we'll debug it real quick, make sure this is working before we get into the UWP applications. And while this is going, the reason I want to focus on this one first is because, as you can see, both the IoT device and the data visualization app have dependencies on the Azure app. Right? So the IoT device is reading to the web app. The client app is, sorry, got that backwards. The IoT device is writing to the document through this cloud service, and then the client app for mobile and PC that's visualizing the data is reading from it.
Okay.
So Azure or ASP.NET first, and then UWP. Publish succeeded. I can see now in my browser, here's my running application. So what I want to do now is actually attach the debugger to that and make sure it works. So I'm going to press a breakpoint on the post event. Go to Cloud Explorer, another tool within Visual Studio. I don't have to leave the IDE. Navigate to my web apps, shop analytics service, right-click, attach debugger. And then that'll try to find the live running process to attach to in my Azure service. So it'll launch the service. And if I return to Visual Studio, once I see the breakpoint is ready to go, I should actually be able to send a post method to my live service and hit this breakpoint, make sure it's working. So I'm using another application called Postman, which is just a simple web debugging tool that enables you to send HTTP requests to any website you want. And what I have here is a pre-filled out body. So I'm going to send an event type, an event to my live service that is event type of true, which means someone has entered the store. And I'm going to send it for today, which it is September 1st.
It is.
So let me go ahead and change this. If it will let me. That's interesting. Post, body. Oh, that's why. I was in the wrong one. September 1st. And this is 8 p.m. global time, so 20 o'clock.
Okay.
I will hit send. I should hit the breakpoint. I hit the breakpoint as expected. It is loading the information. So now I can actually take a look at the variables that are being passed in. So new event, true, event time. You'll see September 1st, 20 o'clock. I can continue to execute this code. And now I should actually see a push notification on my device. So this device had been previously registered for the push notification service. So even though the app isn't running, the data visualization app isn't running, because I had run it in the past, I'll get the push notification.
Right.
So what that means is if I've got my Windows 10 phone and I don't have the app up and running, but someone enters my store, I'll still know that they're entering my store, which is pretty cool. So I'm pretty confident that's working now. I'm not going to worry too much more about the ASP.NET application. Let's actually build the UWP application now. So one thing I'm going to do is actually continue to attach the debugger to this running service, and I'm going to build the IoT app in another instance of Visual Studio. You'll see why in just a bit. So let me open another version of Visual Studio with the solution open. There we go. Oops. And I'm going to actually start from scratch. So I'm going to add a new project to this solution. I don't have an IoT client project yet. So I'm going to right-click on the solution. I don't need Cloud Explorer since this is a client app. I don't need to worry about this controller anymore. And I will minimize that. So let's go ahead and add new project. And I will just select blank Universal Windows Platform application. And I will call it IoT client. So as soon as I create the project, it lets me select my target platform version. In this case, I'm going to choose the Anniversary Edition. I like to play with the latest and greatest stuff. And I'll hit OK. So to get started with this app, and for those of you who have worked on IoT devices before, what you'll recognize is a lot of the code is just boilerplate code that essentially defines where all these devices are registered on the IoT device and the breadboard. So I can say, I know this device is here. I want to communicate with this device. Is it an input or an output device? It's really not any logic. It's just kind of getting everything set up. So I'm not going to write that code. That code's boring. I do want to write the logic. So what I'm going to do now is navigate to the main page of my application. Whoops, that's the wrong one. And I'm going to include that code. So let me go ahead and find that code. Desktop snippets. And I'll walk you through what this code means. It's just not as exciting to write it. Cool. So let's start at the top. I see a lot of squiggly lines. It's because I'm missing some references.
Right.
So to start with, keys, as I mentioned before, is in my portable class library. So I can add a reference to the same portable class library that's included in my ASP.NET application. I'm sharing resources across both apps. The next thing I will see is missing is GPI open. I can hit Control dot to add a reference to the class. If I go further, HTTP client is missing the references. I'm just going to resolve all my references. So GPI, ooh, what's the one up here? Keys. I actually have to add a reference to the portable class library. So GPIO status is actually not something I can resolve immediately. What this actually is representing a text block on the UI. So because it is just a Windows 10 application, in order to help me debug that I'm doing everything correctly, I just added a text block to the UI of it.
Okay.
So let me go ahead and navigate to the XAML. And for those of you familiar with XAML development, this is just a XAML app. I will add a text block, x:\name, whoops, equals GPIO status. I beat the designer, but that's all right. Horizontal alignment equals center, vertical alignment equals center. And then I'm going to make it really big so we can actually see it. 72. And now I should be able to reload the designer. There we go. Now it loads since I closed my tag. So I'm not going to see anything here yet, but when we run the application, you'll see that. So for return to the code behind, that resolves now, no squigglies. And all that remains is 2 event handlers. And I'll explain those in just a second, but that's what makes IoT development with Universal Windows Platform really easy. So I'm just going to create empty methods to handle those for now.
Okay.
And let's take a look at what this is doing and then just deploy it and see what happens. So if I go to the very top, the first thing I'm doing is defining the base URI for my Azure Web API. And this is essentially going to be used to send the post message. So I'm going to construct my HTTP client object with this as my base URI. And then when I send the post message, it knows, OK, target the right live running service.
Right.
These pins, if we take a look at the schematic for this device, are just actually mapped to pins on the Raspberry Pi. So you can find diagrams for the specific breadboard or the specific IoT device that you're targeting that'll have a pin mapping for all of the digital devices that you'll be connecting to it.
Okay.
So if I take a look back to the code, 5 and 17 refer to the pins for my sensors.
So that's what we have here. We have the
So that's what we
sensors
have
there,
here. Yep.
connected to a
Breadboard in the middle.
breadboard.
And then the breadboard has wires connecting to the Raspberry Pi device,
Okay.
correlating to those pins that I specified. So the black wire here is ground, red is hot, so it's the voltage, and then the 4 colors are just different digital devices connected to the pins that enable me to control them through the app.
Okay.
Yep.
So for somebody who is a good C# coder, has done built apps, but hasn't really played with the Raspberry Pi,
Yep.
how long does it take to get to the point where you could wire up sensors like this?
Like this?
Yeah.
Probably a day, maybe
A day?
2.
Okay.
Yep. So I built this in an afternoon, and the only previous IoT experience I had was Arduino based. It was not UWP.
Okay. So you don't have to be an electrical engineer or done soldering
Nope.
and
I mean, so
stuff in the past, right?
the commonality that all
Or
of these
do you?
devices have is that they're all just digital devices. So
Okay.
they all behave similarly. So even though I'm using an IR beam sensor here, it behaves just as a button would. I mean, it's going to have a value of 0 or 1 depending on the state of the device.
Okay.
So if it's a button and it's pressed, it'll have a different value than when it's depressed, just like when this is covered versus when it's not covered, it'll have a different value.
Okay. And is there good introductory material on
let's
how
actually
to...
show you where that is. So if I just search for Windows 10 IoT Core on Bing, what I will find is tons of documentation. So if I just select Learn about Windows 10 IoT Core, there's really great information about what it's like to develop for these boards, including examples that people have built, so an air hockey robot, and then some tutorials as well. So if I click on documentation, and I look at the samples, Hello Blinky is essentially the hello world of IoT development. So I could select C#, C++,
And does it show you how
and it shows you exactly how to connect everything together.
Okay.
Yeah. So to get started, it tells you exactly the hardware you need, how you hook it up together, and here's the pin mapping that I was referring to before.
Okay.
So this is actually the same board that I have. And as you can see here, GPIO2 and GPIO3 are just the numerical pins that I'm referring to here. So 5, 17, 4, and 6 are the ones I'm using. So 17, 5, 6, and then 4 I think is here. So all on the same side.
Cool.
Yep. So it's not too difficult. So that's what those are referring to. Those are just the constant integers that define where I'm plugging those into my Raspberry Pi. Now these are the objects that are actually going to represent those pins. And then these enter and exit booleans are going to be used for the actual logic of the code. So we'll explain that in detail as I'm writing the code. And then client is my HTTP client that is going to be used to send my HTTP web requests to my live running service. Finally, the last thing you need to do is actually initialize the GPIO controller. So you'll pretty much see this method in any of the tutorials you go through for an IoT device development. But once you have all of the GPIO pins determined, first you make sure that a controller exists on the device. And what this means is if I were to deploy this application to a desktop or a phone, it would hit this line, hit this if statement, and GPIO would in fact be null. There's no GPIO controller on my surface. So then it would return out of the method. At least nothing that I can control. So then it would send there is no GPIO controller on this device, and my application wouldn't do anything. That's it. So nothing would crash. I'm only using the universal API set, meaning I don't have any platform-specific APIs. Everything is just common. And then I'm actually opening the pins for those 4 sensors. So as you can see, GPIO pin, I'm defining the sensors and opening the pins. So after that, I need to say, is it an output device or is it an input device? So these LEDs are output devices. I cannot interact with them. The value's never going to change. I can write a value to them. I can say it's on or off, but I can't read anything from it. So when I set the drive mode for the lights, I set it to output. And then the sensors are the opposite. They're going to give me a value back when I cover it or uncover it. So those are input devices, just like a button would be. After that, the debounce timeout is really just to filter out any noise from the IR beam sensors. So if for some reason the value changed for 50 milliseconds really, really quick, like unregisterable, something that was undesirable, it wouldn't actually cause anything to happen. After that, I just create value changed event handlers. And that's really what IoT programming is all about. When something happens, the value is going to change. I have some sensor that changes the value, and then I respond to it. So what I want to do is I want to place breakpoints on both of these and deploy my application to this device. So first I'm going to make sure it's my startup project. Set as startup project. I'm going to select debug. And I'm going to choose ARM because I'm debugging to an ARM device. Raspberry Pi 2 has an ARM processor. Finally, I'm going to select remote machine. It's hooked up to the network. And I'm going to copy the IP address from before and deploy. So while this is deploying, the very first deployment to a Raspberry Pi takes a little bit, but it's a $30 computer, so you can only expect so much. After the very first F5, it speeds up drastically, and you'll observe that in just a moment. So while this is deploying, I do want to explain the logic of how this device is actually going to work. So if we go back to the PowerPoint, I can see this is kind of the overhead view of my device. So if I were looking at it like this, this is what I would be seeing. And I could see I've got my customer ready to enter the door. It's my Ninja Cat riding a T-Rex with the Microsoft flag. And I can see both of the Boolean values are going to start at false, meaning they have not crossed any of the sensors. So as soon as my customer enters through the first sensor, so they've gone halfway through the door, I change the value for my enter device. I know the value of this sensor has changed. I can respond to it, and I can change the Boolean value that I'm tracking. As it continues through the door, I can now see both of those Boolean values have been set to true, or in this case, both of the sensors have been broken,
Right.
and I know an entry event has occurred because entry sensor was fired off first and then exit sensor.
Right.
Now, if the reverse were true, if it went through the exit sensor first and then the entry sensor,
Yep.
that's an exit event. Someone's walking out of my store.
Just went like that and messed with you.
So actually, if you look at
Right.
the GitHub repository and someone goes like this and messes with you so that it messes it up, I actually have a timeout after a couple seconds.
Okay.
If nothing happens, it resets the state of the
Alright.
device. Another example could be, say, a fly goes by and it messes it up.
Right.
Yeah, so there are ways to counteract that, and if you just know some simple C# programming, it's pretty easy to do.
Okay.
But for the purposes of this, we don't have to worry about that case. So as soon as the event is triggered, though, I'm going to immediately reset the state of the device so that when the next customer comes through, it's ready to
Right.
go.
Yep.
It needs to respond instantly. So let's see. So the application is almost done. F5ing. Should take just a couple of seconds.
It's kind of like using an emulator. It takes time to get the
First
whole thing
time,
on
yeah,
there.
eh?
First time, right.
Get everything over there. Yeah, you're deploying to a device that's.
And then this app, along with .NET Runtime, the subset of it,
Yep.
in all likelihood, that runs on this device, right? .NET's already on here, right? The runtime. So you're copying what literally are you putting on there? Just the executable?
So in this case, it's everything that comes with the application. So all of the
Okay.
references, all of my NuGet
Okay.
packages. So it's interesting you mentioned the .NET runtime. So with the Universal Windows platform, you can actually package your .NET runtime as a part of your application.
Okay.
So since this is a debug application, it's not a store application. It's actually deploying .NET basically.
Okay.
However, if I were submitting an application to the store, for example, that shares the same exact .NET runtime as all of the other apps in the store, obviously we're not going to include that version of the .NET runtime with every app. So there are shared frameworks that you can take advantage of.
Okay.
But you can actually change the version of the .NET libraries you want to reference through NuGet. It's pretty cool.
Cool. And then how much storage is on this device? How many
So it's-
apps like this can you get on there?
It depends on your SD card. So I actually have a micro SD card on here. It's hard
Okay.
to see. But that actually has the operating system as well. So if I want to flash this device with a new operating system, I can take out that micro SD card, plug it into my computer, download the
okay.
latest preview build of IoT Core, and plug it back in, and it's
Got
ready
it.
to go.
All right.
Yep. So
Cool.
great. So the application is gone, and it looks like a breakpoint was already hit probably when I reached over it.
Yeah.
So I triggered one of these sensors, and we'll go into
So
more
you
detail.
triggered the exit first
I
because you
triggered-
reached through.
I think so.
So you actually exited the store.
I think so. I always get it mixed up which one's entrance and which one's exit, so
Oh.
might just have to turn it around. But
Oh, okay.
I triggered one of them first. But what's interesting is I just need to know what is happening when that breakpoint is hit. What are the
Right.
values that I'm tracking at this point? So in this case, I can see the value has changed for my exit sensor, and I want to track the arguments that are being passed into this event. So I can just use Visual Studio debugging tools to look at the local variables and see that args.edge is equal to falling edge. And I know that seems kind of cryptic almost, but this is the parameter that you're going to track with most of the digital devices that connect to these IoT devices. And if you did more of the tutorials, that would become more obvious.
Okay.
But even if you don't do the tutorials, you can figure it out just from some clever debugging.
Right.
So what that means is the instant that that breakpoint was hit means the sensor is broken.
Right.
And when the sensor is broken, args.edge is equal to GPIO pin edge.falling edge. So that's how I track if it's broken. If it's unbroken, it's going to be equal to rising edge.
Okay.
And those are just enumeration values. So I can stop, otherwise I'm going to throw an exception, and use that knowledge to finish my logic. So this is the important part. And then for reference, the beam is broken. And now else, the beam is unbroken. There are really only two states for this device, 0 or 1, effectively. So now I can write the logic for my application on here using those if statements.
Yep.
So as soon as the beam is broken, that's when I want to set the Boolean value to true. So since this is my exit sensor value equals value changed, I need to set exit equal to true. Now, if the enter sensor had already been fired, that Boolean value would already be true, meaning this one was fired second. That's when I know an event has happened, right? So if enter, now I'm going to say customer has entered true. That means someone has entered my store. That method doesn't exist. We're going to write it in just a moment.
Okay.
Else, well, exit is already equal to true. Otherwise, I really don't need to do much. So in this case, I actually want to break out of my method and not do anything else. Did that backwards from how I normally do it. Normally, I put exit equals true at the bottom, but it shouldn't really matter.
Okay.
So the only other thing that I want to do, if enter is equal to true, is reset the state of the device as soon as I fire off the event. So I will reset both of those Boolean values to false. So now it's ready to go for the next person.
So the code in customer has entered is what's going to send a message, send the event to Azure.
Correct.
Okay.
Yep. So now, if the beam is unbroken, I actually have a light to track when the beam is broken and unbroken for debugging purposes. That's all that's going to happen here. So as soon as the beam is broken, let's turn the light on. So exit light dot write GPIO pin value dot low. And if you do Blinky, the hello world of IoT devices, that line of code should be pretty familiar.
The light?
So the LEDs, here's a red and a yellow LED in the middle of the device.
Okay.
Yeah. So now I'm just going to copy and paste that to here, and I'm going to write the value of high to turn it off. And that's really all I need to do for this. So I can just copy and paste this segment into the customer has entered method. Oops, sorry, no. The entry sensor value change method. And let's take a look here. So let me lower the output a little bit so we can see everything. So now if args.edge equals GPIO pin edge falling edge, they're the same exact devices. This is the same exact behavior. This is right. Yep. The only thing that's going to change is now I'm working with the entry sensor.
Right.
So enter light, enter equals true. Whoops, entry light. Yes, entry light. Now if exit, so if exit was already fired, I'm actually going to be sending an exit event. So exit was fired first and then enter. I'm still going to reset the state of the device. Yep. That is the same. Else entry light dot write GPIO pin value high. So the last thing I want to do is remove the not implemented exception here and just place a breakpoint to make sure that the events are working as proper or as we expect. Before we send a message to the Azure website, let's make sure we're getting the right expected behavior.
Right.
So now you'll see deployment should be much faster this time. Deploy succeeded.
That was much faster.
Yes, it was. There you go. So the breakpoint is ready to go. So the first thing I'm going to do is just cover one of these. Oops. Sometimes when you have some bright lights like a studio light, it interferes with the sensors. But if I cover this one pretty closely, I can see the red light is turning on.
The light's blinking.
Yep.
Right?
So now if I cover this one, the yellow one, I can see the light's actually staying on because a breakpoint's hit. So the code is not continuing to execute to turn the light off.
All right, cool.
So here I can see, in this case, V is false. That is an exit event. So that is going out of the door. That means if I were to continue execution of the code and go the other way, it should be true. So let's try it. Let's cover yellow first, and then red. So again, breakpoint, and now I see V is equal to true.
Yep.
Red stays on because, again, the code's not going to turn the light off until it continues to execute.
Right.
So that's all I need to know. So my entry and exit events are working properly on the device. Now let's actually do something with that information. So again, just using C# code, I can create my object, triggered event, which I need to first add a reference to my portable class library models folder. Let's call it event. T event equals new triggered event. And I'm just going to go ahead and create the event inline. So event time equals date time dot now. Event type equals V.
So I'm thinking I might actually, I have a theory that when I'm gone, my cat just sleeps all day long.
Now you'll be able to find out.
Yeah, that'd be cool.
You could actually use proximity sensors instead of IR beam sensors. So instead of tripping a beam, if it goes near it, you could also trigger an event.
Right, so you can track things at the home. You can use this as a security device or some type of monitoring.
Yep. If you're one of those data-obsessed people as well, you can figure out where your cat spends the most time in the house.
Oh, I know her.
Just by all
under the bed.
So,
I already know that.
Put a sensor under the bed, and you could actually calculate how much time is spent under the bed versus other places. Yeah. So lots of funny stuff you can do. So I've got my event. Now I just need to actually create the content to send to my HTTP web application. So HTTP content equals new string content. The string itself is just going to be tEvent.toString. And then I'm actually going to use some of the overloaded parameters to send the media type. So I'm interested in telling my ASP.NET application that this is JSON that I'm sending. Because of my tEvent.toString method, I overload it. I can actually navigate to it to return the JSON serialization of that object. And that's so that it works properly with my ASP.NET app. So let me just do encoding.utf8, and then application JSON. And one thing that I always accidentally do is do / or backslash. I always get it confused, so I can make sure I do it right. Application / JSON. Perfect. Cool. So the only thing I need to add now is I just have to post it. So this is the one I want. Content. I should actually give it a name. And now all I need to do is HTTP client, which I already have. Oops, sorry, client. I already have my HTTP client. I don't need to recreate it. Post async. The request URI is going to be API/event, and I'll show you where that comes from, and then the actual content. So the API event is just what's appended to my base URI. So my base URI is shopanalyticsservice.azurewebsites.net. API event is what's at the end. So now if I were to do this.
So how does it know, where did you specify the base URI?
So I specified,
up above, right?
Yes, so I specified the base URI. Whoop. I lost debugging to my live service. Sometimes it times out, so I'm going to attach debugger again, and you'll see why very soon. So up above is where I specified the client information. Base URI equals keys.azureweb_app URI.
Okay.
And then when I actually create the client in main page.load, sorry, it's way at the bottom. Client equals new.
There it is. Okay.
Client equals new HTTP client. So yeah, so as soon as this page loads, what I do is I create my HTTP client with that base address, and then I initialize the board.
Right.
Yep. Cool. Cloud Explorer's. Let's try attaching one more time. Sometimes you get finicky behavior with live running services. So anyways, let's go ahead and actually deploy this application to the device and set a breakpoint when the customer has entered the store, well, or exited, depending on the parameter pass-through. And just so we can track the entire.
So this code's running on the device.
This code is executing on the device.
And you've set a breakpoint. It's going to show up in Visual Studio because you are debugging on the remote machine.
I'm doing remote machine debugging on the IoT device.
That's cool.
Yeah, so remote machine debugging has existed for a long time.
Right.
You could do PC to PC,
Yep.
but now I can do PC to Xbox, PC to IoT,
That's
PC
very
to Surface Hub, Xbox, you name it. So let's see what's going on with this one. My live service is not behaving so well, but that's okay. We'll go ahead. Let's see a breakpoint. Perfect. This should be true. Someone should be coming into the door. So when my local variables load, v equals true.
Yep.
I can hit F5 again. And now what I should see is as soon as it sends the event, it has executed properly. I should get a push notification. But that's where I was saying my live service might. Oh, there we go. So a little bit delayed, but someone has entered the store. So a couple seconds later. Now what's interesting is I can actually view all of the events that I've sent so far again in Visual Studio. So if I go to document DB accounts in Cloud
using
Explorer,
that because it's just unstructured data, no need to spin up a whole database.
So this is, I'm actually
list.
using, yeah, it's just a list. So I'm using document DB, which is a
Right.
NoSQL database.
Yep.
All it is a JSON document. For the demo, I just have a single document, but one of the things we're working on in the repository is making it more scalable to use the NoSQL querying that is supported. So creating a new document for every event, and then a collection for every month, for example, and then we could kind of parse it however we want. But you'll see why I use a single document when I copy and paste all my fake data, and it's really convenient. So if I find my document, see, document DB is very powerful, but I just have my single document. I can go ahead and load.
Nice.
And here we go. So at the very beginning, we did 20 o'clock, 8 o'clock global standard time, and I said true. And then I've done one real event that I sent through the IoT device, which happened just a couple, about a minute ago, which is 1:44, and it's now 1:45.
Yep.
So that is the real event. And I didn't have to leave Visual Studio at all for that. So now, just for convenience, I want to show you another tool that you can use for Document DB to copy and paste the data so you can actually see the data when I run the next app.
Okay.
So in the Azure portal, I can again go ahead and refresh this document. This is the live document. Here are the two events that I was just working with. Now let me go ahead and find my fake data. I have a lot more than just that. And this will actually make the app look like something. There we go. Many more events. So I can go ahead and save that.
Okay.
And now my database has been updated with that data. So Makes it really easy to
It's
test
better
that.
than going like
It's
this
better than going that
1,500 times.
Exactly.
Although you
My arm-
get lots of steps on the band.
My arm would get really tired though. So I'm actually going to break out of Visual Studio 2015 for now. But first I want to deploy the IoT device. So I'm not going to debug it. I'm just going to hit Control F5 to deploy it without debugging. And it'll just continue to run on that IoT device for pretty much ever.
Okay.
So I think one funny example is I went on vacation and deployed it before vacation, came back a little over a week later, it was still running fine. I came back and swung my hand across, saw the lights, saw the push notification.
Cool.
It's pretty reliable, no crashes or anything like that. So deploy has succeeded. I can go ahead and close this instance of Visual Studio. Let me go ahead and get rid of this instance of Visual Studio. I don't know why that debugging wasn't working. That's okay. And let's take a look at Visual Studio 15 preview.
Which preview version is this?
So this is the next major release of Visual Studio.
Right.
Visual Studio 15 Preview 4 is available
This is
today.
4.
This is actually beyond 4, but it's,
Oh, okay.
So this is latest and
Ooh,
greatest. So
all right.
you never know what could happen. Hopefully everything works properly.
So 4 is available publicly, and this is something past that.
Yes, this is
Okay.
something past what
Got
is
it.
available publicly.
All right.
This is one of the beauties of working at Microsoft is getting to play with daily bits of everything. It's awesome. So let's go ahead and take a look at this application. This is what's going to visualize the data. I really just have one page that I'm doing. There's a lot of code that processes the data behind the scenes, and that's where, again, we can optimize our database structure to just do that in the cloud using querying. But for now, we're not going to worry too much about it. Oh, here you go. We might have some IntelliSense bugs with this version of Visual Studio, but I don't think we need it. We're not actually going to write too much XAML. But the designer works, so that's good. So let's take a look at the designer first to see what this looks like. So on a phone, I can see I have a grid here. And it's a little easier to view the structure on a desktop first because of adaptive code. So if I zoom in, I can see I effectively have a grid within a grid. So here's my main grid, is the outer entire rectangle is the first main grid. And in that grid, I have 2 rows. This is the first row, and then this entire thing is the second row. So the first row just contains my coffee shop name, the hours that I'm open. It'll also give me information about when the data was refreshed. Then in here, I have this picture that tells me how many people are currently in my store.
Okay.
If it's really busy and people are like lining up to the door or something, I want to know how busy it is. And then I have 3 graphs that'll be displayed in quadrants. And what I do is I actually write this adaptively so that if it were on a phone, I would just be able to scroll through each of those charts. So I can see here's one of the charts below, and then it's not going to show you the rest because it's cut out of the UI, but I could scroll through it, and I'll demonstrate that as well. So I'm going to go ahead and just deploy this application. And what I want to show here is one of the new features that's coming out in Visual Studio 15 for XAML development to really help you build performant XAML apps.
Okay. Cool.
So this should take just a second. I'll also show you a couple of tools that have been out for a little while now, but a lot of people still don't know all about them. They've only been out for a little over a year. So this application is running. So let me close some of this. So what I want to show you first is what is new. So inside of the diagnostics tools window, we have these diagnostics while debugging tools that run just while you F5 your app. There's a new one called UI analysis for UWP tools. Now this is not on by default since it's brand new. So for those of you watching, if you want to turn this on, all you have to do is click select tools, check on UI analysis, and then you'll have to restart the debugging session.
Okay.
It's pretty painless. But what that does is it gives me a whole bunch of different events about my application and the performance of my application. So the number one is using binding instead of compiled bindings. I'll have to go ahead and fix that at some point. But the one that I want to show you is one that actually surprised me, and I found out about this because of this tool. So let me restart my application. Oh, here's the app. You can see all the data. Let me restart my application and describe what I'm doing that is bad, that UI analysis told me about, that I had no clue about. It's actually pretty cool. So when my application first launches, I can see I don't see much except for this loading ring, right? And what I'm actually doing behind the scenes is I'm creating these objects and I'm just hiding them. So I'm setting their visibility property to visibility.collapse.
Okay.
And what that means is on startup, it's still loading that XAML control into memory. It's having to do the processing to create it and just not doing anything with it.
Right.
And what UI analysis told me is, let me find one of them. Here we go. Element num people in store of type WinRT, it's the charting control, was collapsed at load time. So it told me that. Collapsing an element or setting its opacity to 0 will not prevent the element from being created. So it is creating the element, it's using processing power, it's slowing down my startup time. Well, that's something I definitely want to fix. So not only that, but I can actually, this is going to work. It might be broken because of this. It's the problem with daily builds. So when this is out, if I double click on this, it'll take me to the line in XAML that is causing that to break. So I can actually just go ahead and navigate to it. So num people in store, right here. So here's the chart. So now what I want to do is change one of the properties. So it's going to be hard without IntelliSense, but I can do it. So x:defer load strategy is the way to fix this. Oh, I do have IntelliSense. Lazy. Cool, just I don't have the highlighting, I guess. So I'm going to set a property called x:defer load strategy equals lazy on this chart. And then I have to do one other thing. So I have to navigate to it in the code behind. One other tool that I always do this myself, I've just gotten so used to it. XAML edit and continue is another new tool in Visual Studio 15. As you'll notice, this application is still running. I'm still debugging this app. And I just added that property to my XAML without having to stop anything. And I just did that because I'm used to it now. So I think that's really going to transform the way people create XAML applications.
Yeah.
So I will stop it because now I'm going to have to edit the code behind. Let's go ahead in here. And let me make sure I get the right property name. So num people in store. So the way I'm going to get rid of that warning in UI analysis is I'm going to set that property and then I'm going to call it somewhere in the code where it actually makes sense to finally load that element. So it's not going to be right at startup. It's going to be when I have the data available to actually make that chart meaningful. So I'm going to look at my code and I can see on main page loaded, I get the data and then I set the data context. And as you can see, I already did it for a different control before. But if I do this.findName, num people in store, this doesn't actually do anything, but it tells the code, hey, I need to create this object. I'm trying to do something with this object. So it'll create it in UI. So this is going to retrieve the object that has a specified identifier name. So in trying to retrieve it, it's telling the XAML, hey, you need to create it. So now if I run this again, I should only see 5, I guess, infractions of that specific UI analysis type.
Right.
So here we go. So now if I go back here and I select filter, UI analysis, it's down to 48 instead of 49. Visibility collapsed.
Cool.
So as you're debugging, what's amazing about this is since it's while you're debugging, you'll catch these as you write your code. So rather than waiting until the very end and doing your post-mortem profiling, your app's all ready to go, oh wait, you have 60 performance things to fix on your UI threads. Well now as you hit these issues, you just go ahead and fix them. It's pretty quick. Yeah. So the last thing I want to show is UI debugging, XAML UI debugging.
And can you get those before running? Is there a...
No, so those are actually calculated at runtime. So there's a process running that will tell you that this issue is occurring.
Okay.
So the last thing I'm going to demo is actually in Visual Studio 2015 with this same application. And I want to show it because not many people know about it. Well, hardcore XAML developers definitely know about it now, but there's still a lot of new developers that are not aware of this feature. And I want to make sure it's pretty evident to them that they have this toolbox available to them. So XAML UI debugging is kind of the precursor to XAML edit and continue, which I showed you before. And I think it might be a little busted in Visual Studio 15, but that's what happens when you play with today's build. So let's go ahead and hit F5. It should still work. I've seen that warning before. It's because I forgot to add a reference to my portable class library. But the binary output of this folder is enough to get it to work because in another project I have the reference. It's confusing. But yeah, the app works. I just want to show the XAML UI debugging. So live visual tree, now I can see it.
Yep.
So here I've got this actual adorner in my running application. Let me go ahead. And actually, while this is running, let me show you the adaptive UI nature. So if I make this really skinny, after a certain point, it makes everything in a single column, and I can just scroll down. So the behavior on the phone is I just go ahead and swipe, and I can see everything working. But now, let's say I wanted to change some of the styling on this. Say I don't like the size of Contoso Coffee Shop. I can go ahead and click on the adorner.
Has that always been collapsible like that?
Since update 3, yeah.
Oh, cool. I knew
it's also you can also,
it showed up.
So you can also hide it.
But
with
I didn't know it was collapsible.
This one as well.
Right.
So you can get rid of it entirely if it's interfering with your app.
So while we're on the topic of getting rid of things, go back there.
Yep.
Why is this? This should be in Tools Options.
So that
is
is
a global setting.
A frame rate
I never ever want it. I never ever want it unless I explicitly turn it on. and I shouldn't have to go into
can show you how to get-
app.xaml.cs for every single one and get rid of it. Yes?
Sure. That's good for you. We've actually heard this feedback before. There's two sides of the fence. There's the people who actually do use this information.
Fine.
For
That's why
graphics applications.
tools options. You said it globally.
All right. I'll take that back to my team.
All right.
Thanks for
It's
the
a great
feedback.
feature,
Yes.
but when I'm building an application,
Just gets in the way.
I don't even know if the thing works yet. Frame rate is one of the last things I'm going to check.
That's true.
Never the first thing.
Yep.
Okay.
But you can see, kind of.
See, that's one of the benefits of having a show and inviting
There you go.
folks from the product
Get to
team.
impart your
on.
wisdom. So what XAML UI debugging does is it lets me select that control. And then when that control is selected, in my effectively, this is kind of like the DOM for those of you who
Yep.
do web debugging, I can see all of my visual elements that are at runtime. And this could be programmatically generated controls. If it has this next to it, it means it was user generated in a page.
Okay.
So I can actually click that to navigate to the control in the XAML. So let me actually just show the XAML. So that's the text block that I'm actually looking at here. So this version of Visual Studio does not support XAML edit and continue, but the power of that is I can use XAML UI debugging to find the control.
Right.
Then I can use the Live Property Explorer to modify local properties of it. So I can set that to 30 to make it bigger. I think that looks a little bit better. And now if I were to stop this application and run it again, it would revert back to 24.
Right.
But with XAML edit and continue,
edit and
I could
continue,
then, after
yes.
testing in the Live Property Explorer, I could then edit the XAML file
Right.
while it's debugging, change the values of the property, hit save, and then just keep going. And I don't even
Yep.
need to stop the application. So
That is cool.
yeah, it's pretty powerful. It's one of my favorite new features in Visual Studio 15. Oops. Don't know what I did there. I accidentally hit Alt-Tab. I wanted to go back to this one. Oh, it's still going. But yeah, those are some of the new tools.
Cool.
Any questions?
Yeah, one question. So the Raspberry Pi sends a message to the Azure service.
Yep.
Which then you use Notification Hub to send a message out to the client, right?
Yes.
Okay, so an event-driven model where an event is fired and the Azure service kind of wakes up. That sounds like what Azure Functions are. So did you consider using Azure Functions for the server-side stuff?
So I initially didn't consider using Azure Functions, mostly because I wanted to demonstrate the power of sharing .NET code across all of these different platforms.
Okay.
So I'm using UWP, I'm using ASP.NET, and I'm using the same code for all of them.
Yep.
But Azure Functions would also serve the
Okay.
purpose of what I'm doing.
Okay, cool.
Yep, but just to show this one last time, as I'm running this, it should trigger an event, and I should see current people in store either increment or decrement. Decrement. That was exiting. So now I have minus
okay.
1 people in the store. So if I go this way, then it should go back to 0.
Cool.
And it's pretty fast. So ready? Oops, I might have missed. Oh yeah, there you go, 1. So it takes 2 seconds, 3 seconds to get a
Cool.
notification and update it.
So you could have that, you could have a screen like this in the window of the store, shows the number of people in the store and what the average wait time would be.
I could do that too. Yeah, so I could hook this up to my register.
Yeah.
So one of the things I was considering just additional functionality is
Yeah.
having register functionality in this app. And then I could do how quickly our orders processed, how much
Right.
is the average order. I could correlate this data with money instead of just how many people
Yep.
are in the store. If I'm running a promotion, maybe I'm giving discounts, so more people might not equal more money,
Yep.
etc. But the last thing I did want to show is a couple resources for this. Mostly the GitHub page. I think that's what's
So
going to be.
all the code is up in GitHub
Yep.
for both the client and the server.
Yep, and if you have any issues with it or any questions, raise an issue or tweet me at PM@Mike. This is going to be a living repository for a while.
Cool.
Makes a good sample of all the different services available to you.
And did they open the coffee store? Are they using this?
Are they using it today? No. So this is still just V1. We have to first create our printed circuit board and put it in. No, no, not yet.
Okay.
Maybe someday.
Excellent.
Yeah.
All right, cool. This
Cool.
is a great example. Thanks for coming on and showing.
Not
this
a
to
problem.
us.
Yeah, it's a lot of fun.
All right. Hope you enjoyed that. Take a look at the code, play around with it, let us know what you think, and we'll see you next time on Visual Studio Toolbox.
I've actually got a couple of devices plugged into me. Right now, I've got this band. This is real, and it's modeling my, it's looking at my heart rate. But I'm also a type 1 diabetic, and I've been diabetic for 20 years. And one of the things that every diabetic does when they become diabetic is they try to solve this problem, usually with Microsoft Excel. But at some point, they try to figure out, well, I'm diabetic and I'm an engineer. Let's plug some wires together and see what we can do. So when we say the Internet of Things, I think it's great that you, the normal sugared people, you have your Fitbits, and we think that's adorable. But I have, an insulin pump, and that insulin pump is plugged in. There's the insulin pump, and it's plugged into my arm. It's 24 hours a day, and that talks to a system. Here is a CGM. That is my actual live blood sugar right now. Now you see how it's kicking up there a bit? That's because of stress. That's actually plugged in down here in an implant in my side. Sorry to show you my chubbiness. And this is real. When you hear Internet of Things, you think Fitbit and you think Raspberry Pi, but I think this, okay? And we've plugged this into some cloud systems that I want to share with you. While the Internet of Things is fun, things like Raspberry Pis, this is great. This is a Raspberry Pi, and this is an Internet of Things enabled one. We've actually got some C code on this that is talking to this temperature sensor. So what does that temperature sensor look like? Let me switch over to some code here and show you. This is some C code inside of Visual Studio. This is the low-level stuff. C code makes your eyes blur a little bit sometimes. What you need to know, people who are wearing suits, is you've got IoT Hub and you have Azure devices. So the takeaway there is that that's cloud enabled. But for the developers that think this is crazy, I want you to notice that we've actually got a Visual Studio plugin to do remote debugging of things like Raspberry Pis in Visual Studio. So whether it be high level, updating hundreds of thousands of objects, or whether it's low level and doing remote GDB debugging to a Raspberry Pi, we can do that. Now let's talk about my system. Let me bring back to the slides here for a moment. This is overwhelming. It's Azure, right? It's all these icons. What's going on? There's all these people that are doing all of these things. Well, let's talk about me and the system that I'm building. That's me in my shirt. I've got my band. The band goes to Microsoft Health. That goes ultimately into storage. My glucose system actually goes up into an API, and I pull that data in as well, because that's personal to me. I've got my heart rate over years. I've got my blood sugar over years. What can I do with that? Well, I'm going to show you some visualizations, some graphs. I'm going to plug things into Office and see if Azure Machine Learning can answer some really interesting questions about me and my health. And this is all live, and this is all real. So let's come back over to this machine here. This is a system called Night Scout. This is an open source node application that is running in Azure. And this talks to my CGM, my continuous glucose meter. And I want you to point out a couple of things here. This is the first presentation today. And this is now. That is a real-time system that is showing my blood sugar. And one of the things that happens is not just that I drink orange juice, which, by the way, I have in case I pass out, but also stress. Stress dumps glucose into the system. And this is just one of the things that I have to deal with when I'm managing my blood sugar. Oh, and actually, I'm not sure if the guy can get a tight shot of that, but this just popped up and it will appear in the cloud. It's warning me that I'm now going high. So in a second, the website is also going to announce, and then I'll get a notification on my band and on my watch, and then people are going to start calling me, and then it'll be scary. So, oh, there we go. A notification just showed up. So let's talk about how that notification did in fact show up. So I've got a band, and this is some data in the cloud. How do I see that? Well, it turns out that the band can talk some JavaScript. I can take JavaScript out of the band. This is up at developer.microsoftband.com. You may have a band. You may not be a programmer, but you may have a URL that points to some JavaScript or a blog or some XML, and you want to create a tile. I made one for my blood sugar. So now I've got Night Scout on my system, and I can see my blood sugar right there. What's interesting about this is that I can use this visual designer, but I can also look at the manifest directly, and look at this. That's the code there. Sugar is high. If it's over 150, notification, and then I'll get a notification on my band. This could be done with a build server, whether you want to water your plants, whatever. That is the personal Internet of Things, and that's what makes me happy. But let's think about this. Once my blood sugar is in the cloud, what else can I do with it? Well, I can send notifications. My wife can be concerned. She's probably going to be calling in a moment to make sure that I'm okay. But this is part of the process. But remember how I said I want to analyze this stuff in Excel? Well, it turns out that I'm not very good at VBA, Visual Basic for Applications, right? Remember that 80% of the world's business logic runs in Excel. I think that's a fact. And in fact, there's an Excel JS API, JavaScript API for Excel. I can write an add-in for Excel in JavaScript using the web technologies that I know how to make. So we went and we made the Hansel Sugars project. And I'm going to actually show you some of the code here in just a second. Here we go. Where we're going to populate a table in Excel using JavaScript, using web technologies. And what is exciting for me about this is that I didn't know how to do this before. You see, I'm a web developer. But now I can go in here and put in my target range, hit refresh, and now we're going to go and talk to the back-end system and then dynamically populate a chart in Excel of my blood sugar that I could then send to a doctor or my wife. You have to think about the sense of power and enthusiasm that I suddenly have for Excel, which I did not care about before. I'm a web developer. That's a web application in pain there. And it works in Excel online. And one day it'll work in Excel on an iPad. Like, once you learn how to use one Lego piece, you can then plug them into other stuff. So it's extremely heartening for me to be able to do this. And again, if my blood sugar isn't interesting to you, and it shouldn't be, maybe some hobby of yours or something at work or some inspiration will come into your mind and you'll think about how you can plug these things in together. That's what's so exciting about this. So I've got all my blood sugar in real time. I can collect it into the cloud. What else can I do with it? Let's switch over to another machine here. I'm going to switch over to a Mac. This is a Mac running VS Code, and this particular Mac has got the code to collect my data from the Health API. Okay, so we're going to go and make RESTful API calls, big standard API calls off to Microsoft Health, which is where the band data is stored, because this is the thing that's so important. It's my data. It's my heartbeat data. My blood sugar is my data. So once I have that ownership of that data, what can I do with it? I can plug in that data and do different stuff. So let me see if I can jump out of here. This has gone full screen. Full screen can be a little confusing. There we go. I'm going to take that data, I'm going to pull it out of the Microsoft Health API, and this is a storage explorer. The reason I wanted to show you this on a Mac is that this is the Azure Storage Explorer that we've released that is cross-platform. We're looking at the CSV files of my blood sugar data as it's sitting in the cloud. Excuse me, my heart rate data, pardon me. I'm going to hit download. I'm going to throw that on the desktop. Watch the right side. Now I have power, now I have control, now I've got a hold of that and I can run analysis on it. Now in this case, I just brought it down to the desktop. I could do some test notification about my blood sugar. I've got, and I can do some analysis here, but maybe I want to do that analysis in a more sophisticated way. When you start thinking about the Internet of Things, you start thinking about huge amounts of data. I said it has my heart rate. Well, like how much is that? Well, I mean, is it an average over a minute, over 5 minutes, over hours? This is a huge amount of data. My blood sugar is doing 300 or 400 data sets every single day over the course of a year. This adds up to huge amounts of information. This is where simply putting it into Excel and sorting and going, it looks like a pattern, isn't going to be enough for me. I'm going to need to do some machine learning. I want to find out about why does my blood sugar go up when I'm stressed out? What does Thanksgiving dinner look like? Maybe I can answer those questions with machine learning. So I'm going to switch back over to this system here. And what I'm going to do is I'm going to jump into here. This is a machine learning kind of algorithm that I've put together, an experiment, if you will, to pull in data from the heart rate on the right there from Azure Storage and the glucose data. And I'm going to come up with a stress index. I'm inventing a number. It's the Hanselman Stress Index. And we're going to load that data up. And what we're going to do is clean it up, do a little bit of normalization, do a couple of analysis, run some statistics, and then come up with a data set that the result is going to be a time-based data set of my stress. Okay, so that's kind of interesting. It's pretty powerful, though, but I need to see it over time. So how would I express this over time, and what value is there in it? Well, there is this API in Office 365 and all of Microsoft called the Graph API, right? The Microsoft Graph, graph.microsoft.com. And this allows me to pull my information. Remember how I kept stressing? It's my blood sugar and my heart rate and my calendar and my email. I want a unified API to go and get those things. And the Graph API, and you can see there at graph.microsoft.com, allows me to make those requests. So what if we looked at my blood sugar and my stress and my heart rate over time, overlaid on an Office 365 calendar? That could give us some insights. And again, I don't know anything about this stuff. This is what's so important and why as a developer this is so exciting. I know JavaScript, I know the web, I know C#, and now I'm feeling comfortable about the cloud. But when I see, hey, this is an API and it uses JavaScript and I can access all of the graph data in Microsoft, that's amazing. That's a playground of excitement. So I can go and build this, get a start date and an end date. This is all standard parsing of JSON, parsing of JavaScript, all using the Graph API. Let's go and see what kind of a question that could potentially answer. So here is my calendar, the stress index as it applies to calendar data. Let's click on one. This is all real. Okay, so here's glucose is updating. I can see the different rehearsals, and I can see heart rate and sugar and stress changing. I can actually run queries and see the result of that machine learning and ask the really burning question, the question that we all have, which is what is the most stressful person in my life that is causing these problems and raising my blood sugar? Darn it. It is a really, really great time to be a developer. I can put stuff like this together now. It is an extremely personal time. It is an extremely empowering time. You know how we keep telling everyone, teach the kids how to code. Everyone needs to learn how to code. That's a part of it. But we need to teach people how to think about systems and how to plug stuff in. I don't know the Graph API, but it made sense because it's using open web technologies. I don't know a lot of open source systems, but I'm learning those libraries and I'm bringing them in because they're using open tech. .NET is open source. If I have questions, I can look at the docs, but I can also read the source. Maybe I want to run a Mac. Maybe I want an iPhone. I can build those systems with the mobile tools in Visual Studio. Maybe I want to run on Ubuntu. Then I can use Visual Studio Code, and I can write Angular, and I can use Go. I can run those things in the Azure cloud. It is such an exciting and powerful time to be a developer right now. I really hope that you have as much fun building stuff as we have had building this stuff for you. And I really look forward to seeing what you all can build. Thank you very much, and have a really great day.
Shall we get this party started?
Is everybody in?
Let's do it. Thanks for coming, everybody. My name is Cameron Skinner, and over here to my right is Doug Seven. Doug, you'll notice, is not Sam George. Sam George was supposed to do this talk with me, but came down with something nasty, which rendered him completely useless. So I went to get Doug, who's a little less useless.
Marginally less.
Just a little bit. So I am the director of engineering of Azure IoT. So it's my team that builds the Azure IoT Hub, which is one service in the Azure IoT collection of services that we've talked about. Doug, you want to introduce yourself?
Yeah, my name's Doug7, and I work with Cameron on the Azure IoT team. For the last, I don't know, year and a half or so, I've actually been working in our DX group, which is our Developer Experiences group, where we do outreach with customers and communities. And in that time, I've been working with a lot of customers who have been working in the IoT space, creating new devices to do new things in new environments and connecting up to the cloud. And I've been working with Cameron and his team on what that means for real customers, and they made me come work for him.
It's all part of the plan. So what we're going to do is we've got a decent talk, lots of demos, and then hopefully we'll have time for some decent question and answer kind of thing with these mics here in the middle of the room. So with that, let's get going.
Yeah, we have a few things to cover today that we'll talk about. So this is sort of the roadmap of what we'll spend the next 58 minutes now talking about. And like Cameron said, we have a lot of demos to show, so we'll get things underway pretty quickly. We'll start by talking about the IoT revolution. You're all here because you're interested in IoT. IoT represents, we think, one of those really pivotal shifts in what happens in the developer community and in the world at large from a technology perspective. If you think back to the sort of mainframe to PC transformation that occurred, and as Microsoft developers, maybe even the transformation that happened about 16 years ago or so when the .NET framework was introduced, it really took something that was conceptually around and had been around for a long time, but really made it very approachable and very easy for developers to start working with these frameworks that would give you an abstraction of the underlying technology. That then went into a transformation around mobility and smartphone, which probably, I don't know, 10 years ago was really a big transformational point for how we thought about computing and computing technology and computing power. And we went from, mainframe went from these big computers to these sort of portable computers, and then we went to computers that fit in our pocket. Now we believe we're at this other technological transformation where we're going to these very small, low-powered computing devices that can be embedded in things or put in things or scattered about, and they're going to create, the IoT devices and the IoT services are going to create another one of those sort of epic shifts in technology and how we work. And many of you are probably already seeing that today, which is why you're here. And the services that we're building in Azure are meant to support that transformation and make it easy for you to work in this new space. All of this is supported by some theories and laws that exist in technology. And these are here really just as proof points to represent that things like Moore's law that talks about the number of transistors in a circuit doubling every 2 years, or Kumi's law talking about the actual transactional power of a circuit based on the amount of electricity it consumes, the joules of electricity will double about every 1.5 years. What these mean together is that we have much, much smaller devices that are capable of doing much, much more than they were ever capable of doing before. Those two laws come together to basically say that.
And just to add to this, if you listen to or read a lot of the analyst reports, everyone's trying to figure out, hey, listen, how many devices are there? What are we talking about? How many sensors are we talking about in the near future? You see a bunch of numbers, but one that sticks out to me, I think it was a Gartner report that basically predicted in 2020, we're expecting 50 billion sensors out there. Billion. B. So even if they're, 50% wrong, that's still a lot of devices.
Yeah. See, that's why he's a director. He listens to the analysts.
Math is hard.
Metcalfe's law, of course, the network of devices, the number of devices, the value of that network is squared by the number of devices. All of this is what makes IoT really compelling. You are getting smaller and smaller devices that are more and more powerful, and we can now start to build these networks of devices and things, and we're going to create a lot of data and do a lot of stuff with it. So it all starts with a great idea.
Like a shirt that lights up.
That's a great idea.
It says Azure IoT. That was awesome.
A connected shirt would be fantastic, or some headphones or something like that would be incredible. Starts with a great idea. And I talk to people all the time who are like, oh, I've got this great idea, and now I got to go do something. And so then you think, well, the idea is driven by all these questions. What if my device could tell me when they go someplace? Like my shirt could tell me when it left the house, right? Or what if I knew what my things were going to break before they broke, right? I want to know, kind of like a check engine light. I want to know before it breaks that I need to do something about it and react to it. What if I could tell when it's the best time for my thing to do something? You think about this a lot in energy or in heating, where the cost of power is variable based on time of day and usage, and so understanding time is really important. What if I simply knew where my things were? I lose my things all the time. Having something that would tell me where they are would be great, or if you're in the shipping industry or logistics or something like that. What insights could I get from all of my devices when I have this network effect of all these devices collecting data and bringing it into me? What are the insights I could derive from that that I could learn from and I could do something different than I'm doing today? And what if I could use device telemetry to improve? Now, Cameron and I actually both came from working in Microsoft's developer division where we worked on Visual Studio. Who here uses Visual Studio? I thought so. OK. One of the things that we've done in other Microsoft products, including Visual Studio, is when you install it, we ask you if you're willing to send us data about your usage of that product to help us make that product better. And we take that data and we look at it, and it's usage data, and we derive insights from it, and we use that and apply it into our engineering practices to make a better product. What if you could do that in the device world? What if your devices could tell you about what's happening around them and what's happening with them, and you could use that to create better things? Imagine if a car could tell you how it's being used, and you're an automaker, and you can use that data to then make a better car, right? So it starts with a great idea, so then comes the device. You have to then build the physical thing. So you build a device, and then you start getting data from that device, and that's awesome. We all like that. And then you have to think about, oh gosh, now I got to secure this device. I got to lock it down. I got to do some encryption. Then I start getting insights from that device. So now it's sending me data. It's totally secure. I'm really happy. And I'm starting to get insights from how it's being used. And I've got one of these things, and I'm learning from it, and I'm building my system, and that's great. And then I make more. And I make more devices. And that makes a lot more data. And now I've got 100 devices, and 1,000, and 1,000,000, and 2,000,000, and what was it, 50 billion?
50 billion.
Devices sending me data. I'm monitoring that data in real time. I'm getting insights from it. I'm getting value, real business value from that device or those devices. And then I start thinking about things like machine learning and other insights tools to start looking for patterns. And I want to start clustering things. And I want to start understanding how they're being used and really get that insight from that data over time. And then I have to think about, OK, I got one, and then I got 100, and then I got 1,000,000, and then I put them out in the field. And now I've got an update. And now I've got to update those devices, and I've got 1,000,000 of them or 50 billion of them or whatever. And then I want to start visualizing all that, and I want to manage those things, and I want to group them, and I want to do all these things with them. And that is hard. Like, that is really hard. Who's doing this already? Yeah, because it's hard. There's one guy. He's like, yeah, I'm doing that. It's really hard. So the idea behind what we've been working on in the Azure IoT services is what can we do to make that easier, right? What can we do? So without getting too sales pitchy, we have a bunch of services that enable this, that take the pain away from you and make it easy for you to just think about your business and what you're trying to do with that data and get it in there. Everything from IoT Hub, which serves as that cloud-based backend for your devices to be registered with and to provide some authentication and authorization of those devices, or deny a device if it's become rogue or any of that stuff, to Stream Analytics, where I can start looking at that data in real time and building rules around it and making some decisions, storage, services, Power BI for visualizing that data, logic apps, everything. All of these services are designed to support the IoT space, and when they come together, you start to think about the solutions that you could build with them and what you can do with that. So there's a lot more to it. So it kind of looks like this. So, right, this is the solution. It's clear where the starting point is. You know what you have to do. You know what you have to build. You start with one of these.
That's obvious, right? Just pick one.
Totally. I'm going to pick.
Are you feeling lucky, Doug?
Hold on. Wait for it. I lost it. All right, so Cameron, make it easy for me. Make it easy for me.
I think we can do something for you, Doug. So how many folks saw the keynote this morning? OK, so you saw, I touched a little bit about what the Azure IoT Suite is all about. And it really is about making that situation Doug just described a whole lot easier for you to deal with. This is really a quick a reference kind of architecture of what the Azure IoT Suite, it deploys a pre-configured solution into your subscription. And this is the kind of architecture that it generates for you automatically without you having to write something. And so it allows you to connect. It generates a bunch of simulated devices. And I'm going to show you this a little bit more. But it generates a bunch of simulated devices and also allows you to connect actual physical devices through UI. And it gives you and automatically deploys an IoT Hub, which is your telemetry ingestion data point. And then feeds that to Stream Analytics, where you can associate alert values. And we've got a couple example alerts that are really just as Stream Analytics jobs. which then feeds back into event hubs and web jobs and storage, and it's all these things together shows that dashboard, which I'd like to get into now.
Absolutely. Why talk when we can show?
Yes, exactly. So if you go to, here we go. If we go to AzureIoTSuite.com, you will see, most likely you'll just see this one tile here. This one is actually a solution that I've already pre-deployed, but I wanted to kind of go through what it looks like to create one of these solutions. And right here you see two pre-configured solutions, and I mentioned this in the keynote this morning. You've got a predictive maintenance solution and a remote monitoring solution. Well, which one should you use? Well, the idea is these are pre-configured solutions that will exemplify some significant piece of this IoT challenge that we've presented, Doug has now presented you with. The predictive maintenance is if you've got a problem or you want to do some what-ifs around a maintenance-like scenario. The scenario that you see here is that you'll see in the predictive maintenance solution is we've attached Azure machine learning to the back end, and there's twin turbine engines that we basically show you the Azure ML algorithms that will attempt to indicate to you based on the runnings of those turbine engines when they actually need maintenance. So if you need an example of how to use Azure ML with your devices, this would be a great choice to do. Now, the remote monitoring is a more basic, but actually a more common kind of scenario, which is just, look, I've got devices, and I need to control them remotely. And that's what remote monitoring is all about. So I'm actually going to go in there and show you this in more detail. And so here, it requires a unique name, and I'm sure build 2016 is not unique. So I'm just going to add a few more numbers to it until it is unique. OK, there we go. This is built, I'm jumping way into the future on this one. Then you select a region. And this, again, think of this as you're going to select a region where this solution is going to go and deploy into. I'm going to pick East US, and actually, let's do that West US. How about that? And then a subscription. And you pick a subscription, and then you say create solution. Now, before I do that, you'll notice that when creating this, that huge slide that Doug showed you, this is a list of all the things that this is going to go and deploy for you automatically, okay?
So that's where you start.
Yes,
Got
yes. Yeah, it's pretty simple. Yeah. So I hit create solution, and away it goes. Now, this generally takes, like I said, about 5 or so minutes, and so I'm just going to let that go and then jump back over to the other portal and see, once you see it, it says it's provisioning here, and if I actually select this, you'll actually see, hey, we're provisioning log, and it shows you what it's doing while it does it. Okay, but like I said, that'll take 5 or so minutes. So what I'm going to do in the meantime is I'm going to go show one that I've already pre-deployed and call out a couple things here on the right. So just the act of selecting this, you will see where this thing was deployed, the subscription ID, et cetera. But the thing that I want to really point out to you here is where the source code for this solution, where that resides. Because all the code that is driving this dashboard that you'll see here is in a GitHub repo that we've open sourced. And so all of that code is stitching together. That's what I meant when I said, hey, these pre-configured solutions stitch together all those back-end services that Doug showed you. It stitches all those things together to show you how to use them and how to do something like this solution. Okay? So I really wanted to call that out for you. And then links to developer documentation here, et cetera. I can make that a little bit bigger so you can see that. So here,
let's hear it for GitHub.
GitHub, yeah, GitHub source repo and the developer documentation. Okay, now let me launch the solution and just go into this a little bit. And actually, this is a good security measure that after a while it'll just die out and you got to log back in. Okay. So what you see here, there's no code to write. I gave it a couple different things. Remember the solution ID, and boom, you get all this information. This is a live map. This is showing you, if I select these, this is showing you devices. And now this particular one is a simulated device that we've generated. In fact, if I click on devices, there's a simulated device, and actually I have a physical device that I was using during the build, the keynote, which I don't have right here, but this is a simulated device. And this also allows you to do a number of other things, like set up rules, like I mentioned, and this is where I set up this rule that I used during the keynote, which was the temperature goes less than 20, away you go. And you can create custom ones of these. You can create actions, such as an alarm humidity. You want to raise an alarm, et cetera, et cetera. The idea here is give you enough infrastructure, make this app comprehensive enough so that you can get in and do some what-ifs. A lot of companies and a lot of our customers that we are working with who are really interested in this turn out to be folks that aren't technically deep like you folks. These are folks that say, look, I own this business, and I know I've got a bunch of hardware that's generating a whole bunch of data, and I just want to understand what's possible. And how can Microsoft and Azure help me with that? This is a great solution for that, because you can get in here and you can start to play with things, and you can start to do those what-ifs, okay? That's really what we built this for. And then, of course, we make that open source, we put it in GitHub, and in order for you to then, for that person to then turn around to you type of folks and say, can you do something with this source code and do something a little bit more specific to my domain so that I can then go and take this higher up the chain, let's say. Does that make sense?
The idea behind the IoT suites is really, you can get started in minutes. Cameron can show you, you're going to take 5-10 minutes to provision one of these. And then once you understand it, you can really customize it to meet whatever needs you have. And we've seen customizations of IoT Suite that are actually really quite incredible when you start applying them to your own business domain.
Yeah. So we're not going to wait for this. This is still going. By the time we're a little farther down the road, this will be done, and I can actually bounce back over and show you what that looks like.
All right. So we'll come back over here. So you saw Cameron show you the IoT Suite remote monitoring service architecture. We kind of walked through it before. It starts with IoT Hub, which is what we build. And then those rules he talked about, where you can create the rules, like when the temperature goes below 20, turn the T-shirt on. That's based in Stream Analytics, where you can create these jobs that run, and they look at that data as a data stream coming in real time and can react to it and do something interesting with it. You can start putting it into storage and do something with it later. This is a great way to work with things like machine learning. And then you can have Event Hub coming out of that Stream Analytics job, set you up for different web jobs. You can work with apps and business processes and connect all your things to things that are of value to the business, web apps and Power BI and Active Directory and all these great things. So what you saw was the total encapsulation of all of this with either simulated or real physical devices that you can connect to this service and just make it work. So all that complex stuff that we talked about, we wrapped up, put it in a package. You can deploy it in 5 or 10 minutes, customize it to meet your needs. So IoT Hub is designed for all these great things. IoT Hub is a component of that solution, really designed to be the back end to all your devices, to give you that ability for your devices to connect, give you the ability to do what we call device-to-cloud messaging, so sending messages from your device into a queue in IoT Hub, or cloud-to-device messaging, so sending messages from the cloud back down to those devices, monitoring them, using different protocols in the IoT space. There's multiple protocols in use. We support AMQP, MQTT, HTTP. We have some tools to support AMQP over WebSockets if you want. So a lot of capability built into IoT Hubs as the entry point for your connected devices into the larger Azure service system. To support this on the device side, so we've been talking about sort of the cloud side and all these services. To support it on the device side, we've created a device SDK. Again, open source, lives in GitHub. You're more than welcome to contribute to it if you want, but we're actively working on it. It's open source, it's cross-platform, and when we say cross-platform, what we mean here is for all these little devices, some of them run real-time operating system, or RTOS, some of them run Linux, some run Windows, some run iOS, some run Android. We have device SDKs for all of those platforms. It works across those platforms. You can develop in different languages depending on the OS you're working with, so C, Java, Python, C#, my favorite, Node.js. I love doing Node.js applications on small devices. Xamarin compatible, which, not to steal Cameron's thunder, but we're going to see in a minute. Super easy to get started out on GitHub. You can go up there, you can start downloading the client code and start working with it. This morning we announced Azure Certified for IoT Devices, We have about 50 partners so far that we've certified their devices to work with Azure. And all that means is those partners have taken their devices and connected them up to Azure IoT Hub, run some tests that we've provided them, and shown that their devices are 100% compatible with Azure IoT Hub. That doesn't mean those are the only devices compatible with IoT Hub. It just means that we've done the work with those partners to prove that they work. So 50 different partners and growing every day. We're working with new partners all the time to certify devices. Everything from little tiny devices that are the size of my fingernail to bigger devices with more power and more capability. Everything from Raspberry Pis, Intel Edisons, BeagleBones, a bunch of them Freescale, all kinds of them. So I'm going to turn it over to Cameron again to show us some of that device SDK and cross-platform support, if you don't mind, Cameron.
Sure. So what I'm going to show you here is I've built, basically I'm going to show you a couple different things. I want to show off the cross-platform nature of the SDK. So I'm going to spend a lot of time using Node.js. I happen to be running OS X here. I'm using Node.js. I'm going to use Node.js to show you how to create or provision a device with the hub. I'm then going to go and jump into Xamarin to show you an iOS app that can then real easily talk to the Azure IoT Hub. And then I'm going to show you a Node.js app that actually connects up to the Azure IoT Hub, say that fast a couple times, that sends a message back to this client, and you'll see that communication. So the first thing that I want to do is I'm going to go into VS Code, and I want to show you the script that I'm going to execute here. Let me make that a little bit bigger for you. I'm going to show you, basically, this is the script that I'm using to provision a device, to create a device so that Azure IoT Hub understands what that device is and can communicate with that device in a secure way. So I'm going to bounce back over here, and I'm going to go into my create, and I'm going to run my create device identity.js. Let me bring this up here so that folks in the back can see this a little bit better as well. Can you guys see that okay? Yeah?
If you applaud like you can see it, the guys next door think we're doing really good.
Yeah.
All right.
Okay. That was cheap. Okay. Okay. So let's do that. Let's create the device identity. And now what you see here is the name of the device, which that was the name I gave it when I'm provisioning, and then a device key. And this device key has now been registered with the hub in order to create a connection string that's specific to this device. Now, where is that connection string? Well, if you read some of the docs, you could get at this connection string in a number of different ways. But we've recently updated the Azure IoT Hub portal in order to make these kind of things, getting these device connection strings a little easier. So let me go bounce over here. Here I have the portal, the Azure portal, and I've got an IoT Hub here. And you notice this says devices for folks that can't see that in the back here. Devices. And this is we just put this in, I don't know, a week and a half ago. So if you haven't been on the portal lately, this is brand new. Basically what this does is it gives me a list of all the devices that are actually provisioned with the hub. And so in this particular case, this is the device that I just created. And here are all the connection strings that I would need to communicate with the hub. And so what I'm going to do is I'm just going to put this on the clipboard here. And then I'm going to bounce over to Xamarin. And I'm going to create a new solution. And in this case, I'm going to create that iOS. I'll just create a single view app, keep it simple. I'm going to give this a really spectacularly unique name and go in and create a Xamarin solution. OK, now at this point, nothing new going on here. However, what I need to do, the first thing I need to do when I get in here is I need to right-click on the project, and I want to go to Add, and I want to say Add NuGet package. Because what I need is I need the Azure IoT Hub SDK. So what I'm going to do is I'm going to type in Microsoft.azure.devices in order to get a list of the NuGet packages associated with the Azure IoT Hub. And in this particular case, you'll see Microsoft Azure Devices Client PCL. So what we recently did is we created a portable class library that wraps up our Azure client SDKs in a way that Xamarin can then use. So what I'm going to do is I'm going to bring that in. I'm going to say add the package. And then that will pull down that package and any dependencies it may have so that I'm ready to use that inside Xamarin. Okay? So now what I'm going to do is I'm going to show off my UI skills. And I am going to build a really complicated, extraordinarily complicated iOS app that will consist of 2 buttons and a text view. And basically what I'm going to
stepped it up from console.
Yeah,
That's
thank
good.
you. So the first thing I want to do to show you guys is I'm going to create a button on this storyboard. And again, this is an iOS concept. And I'm going to find a button. I'm going to drag this thing out. And let me resize this thing. Whoop, having troubles here. Let me resize this and name it. Called it send message. Okay? So I now need to go write some code that handles this send message.
Can
now,
we just hear it for your UI skills, quite frankly?
Thank you. That was really, really amazing. Yeah. Okay. That's really painful.
That'll be on my performance review, I'm sure.
Yeah, that's not good. Okay, so what I'm going to do here is I'm going to do some, I'm going to do that, which is basically a code snippet that I'm cheating a little bit here. However, I need to take that device, that connection string here, and I need to paste it in here. And I just messed up. I hit the Command C, so let me bounce back over here, copy that again, come back over, paste, there we go. And so what I'm doing here, and let me resolve some of these dependencies. So very much like in Visual Studio, Xamarin also has the way to resolve type dependencies, so I jam in the correct using statements that I need. So because I added that PCL package, I can then say, okay, yeah, I need the using Microsoft Client SDK, and then I'm also using this encoding, and I need to use the system text. Okay, so now everything should resolve appropriately. But this is all you need. 4 lines of code is all you need to make an iOS app talk and be able to send messages to Azure IoT Hub. That's it. That's a place where you probably generally...
Like, really? I didn't think I'd have to ask. I thought it would just happen.
It's a long day. OK. So real quick, we've got the device client creates that connection string. Using the connection string that I pulled from the portal, I'm going to send a message to the hub called hello from iOS. And I'm going to new up that message and then send it. Okay? It's that simple. But now, how do we see it? So I'm going to send this to the IoT Hub, but how do you know that it actually got there? Okay, let me jump back over here. And what I want to do is I've created another script here called read device to cloud message. And now this script is this is still Node.js. It's a little more complicated because this Node.js script is actually attaching itself to the back-end stream where messages are coming through the hub. And this code right here is it handles all the heavy lifting to connect to the proper partition and pull off the message. Okay? And so if everything goes well, you'll see this script say, I'm going to listen to 4 different partitions, because by default, when I deploy an Azure IoT Hub, we use an event hub on the back end that has 4 default partitions, which you can listen to. And so once that does that, then it's just going to print out, once it gets an event that hits a queue, I'm sorry, not an event, and a message that hits one of those queues, it's going to print it out. So let me run that script. Node, read, device, cloud messages. And so you should see this thing connect and then listen on various partitions. Okay? So now this little Node.js script is sitting there waiting for a message to hit the hub. So now let's go send in a message. Okay, let me go back over to Xamarin, and let's build this thing. Now, this is going to do the classic build. But then the other interesting thing is it's going to fire up the iOS simulator. Now, this is the iOS simulator. I'm running on an OS X box. This is the simulator that you would see. So now let me scroll into view there. Again, I mentioned my UI skills. I didn't even get it on the screen. That's awesome. I send the message, hello from iOS. OK, let's do it again. Send a message. That's awesome. So with those 4 lines of code, I sent that message to the IoT Hub. OK, cool. But we're not done yet. I want to now write a Node.js script that sends a message to the hub that is really targeted at the device that's here, this iOS app. So this is called a cloud to device message, okay? And you can do that through the Node.js SDKs as well. So let me leave that simulator running. Let me hop back over here. And I need to add some more UI. So let me get a button here.
Buckle up, everybody.
Yeah, here we go. OK, let me make this a little bit bigger. And I'm going to call this receive message. Receive message. Awesome. Thank you. I answer. So painful. OK. And now I've got another little snippet here called C2D, and a little bit more complicated code, but not much more. I'm going to paste in that connection string again. And I need to resolve one little bit there. And, oh, yes, I need to do one other thing. So what I'm going to do here, again, this is a receive. So this app is going to get a message from the hub, a message that I sent from the Node.js little client that I was just playing with. And I'm going to put the received messages into a text view, which I am going to draw right now. So let me do that. Text view, drag this out, drop it there. Excellent. Let's give it the name that I'm going to refer to it by in my cloud, in my code behind. Let me remove all this nonsense. OK, and I think I'm good to go. Let's give this a shot. So now, let's run this. Make sure everything's happy. Excellent. Excellent. OK, there's my new UI. OK.
I love your alignment, by the way.
Yeah, you like that? I spent a lot of time with that. OK, so I'm going to kill this one, and I'm going to go over to my send. And now what I'm going to do is this. Let me show you that code. I didn't show you the code. In my send CD message. So here's what the send looks like. I'm creating another client because I'm running it from this OS X box. I'm connecting to it, and I'm looking for a specific device, right? And I'm going to open the connection, and on an interval, I'm going to send a number of messages for the next two seconds. And you'll see here, hello from Azure Cloud, and I'm simply incrementing the message number. Okay? So you'll see for 2 seconds, I'm going to generate a bunch of messages. And this is key because the command and control from Azure IoT Hub is actually queue-based. So if you have a device that's offline, we're not going to lose the message on you. Right? So it's going to queue up, and then it'll be, the device, well, it'll be a first in, first out. Thank you. First in, first out from the device. Okay, and let me show you what that looks like. Okay, so if I'm going to run the send C2 message, it's going to connect, and then it's going to start sending messages. Okay? So the message is in queued. Now, I'm over here. And now all I need to do is, on this device, I say receive message, and if everything works, I should get the first message that went into the queue.
Notice the number in the message. If you look at the JSON, there's a number indicating the order in which they entered the queue.
Yes. So if I keep clicking receive message, you should see 2, and now it'll go to 3. And guess what the next one's going to be? Yep, 4 and 5, right? It's pulling off the queue. OK? Thank you. So I hope that wasn't too complicated. Basically, I just wanted to emphasize the fact that we've got this cross-platform capability in the SDKs that we're trying to make it as easy to use as possible, regardless of what type of device or what language that you are really in love with. Use anything. We're really trying to make it just whatever you need, however you need it. This should work for you.
Exactly. And depending on the device you're using, the language may be dictated for you. So,
yeah.
Fantastic, awesome. Obviously, you don't have to have something where you click a button to get a message. You could be constantly receiving messages, but it was a great way to show the queuing mechanism and how it works. You can imagine a wide variety of scenarios in which you would have a device or an app sending messages to the IoT hub, and another device or another app receiving those messages back. A huge variety of scenarios. For the remainder of the time, I want to talk to you about new stuff. So most of what you saw has been out in IoT Hub already. We've made some incremental improvements to it. I want to talk about the new stuff that we announced today and what it means, because it's actually quite cool. So we have a bunch of things. I'm going to walk through all of these, so I'm not going to spend a lot of time right here talking about them. But we have IoT Hub device management. We announced a new Gateway SDK, some IoT starter kits, and some new Azure region availability. If you remember, Scott showed the little tiny truck and the big thing. So let's talk about device management real quick. We showed how you can do messaging with these devices, and we talked about the complexity around when you have these devices out in the field and how do you do things. Right now we have all the ability to do CRUD operations on devices. I want to create a new device. I want to do other things with it. I want to send messages back and forth. The device management gives us the ability to really do more than just say, I've got a device and it's sending me messages, or I've revoked a device and now I no longer get messages from it or send messages to it. But instead, we have the ability to do things like manage those devices, do software or firmware updates to those devices, handle configurations. We can group those devices into topologies or subtopologies. All of this is based on a set of standards from the Open Mobile Alliance, the lightweight machine-to-machine protocols, very common open source protocols that are used all throughout machine-to-machine and IoT scenarios. So we're right on top of all the most common standards that are being used. You get to manage the way you talk to devices. You get to manage the way you work with devices. You get to do it the way you want. And you get to really focus on better orchestration and better collaboration between your IT group and your operations or OT group. So device management is huge. When we think about that, what does that look like? You can imagine, like, we'll use the building management scenario. We have lots and lots of devices in a building or in multiple buildings or across a campus or wherever it may be. And so you can do some logical grouping of those devices and say, okay, well, here in every room I've got a temperature sensor and a motion sensor, and I use that to control if I see motion, then I turn the temperature up and turn the lights on, and if there's no motion, I do the inverse. And so I can organize those by rooms, and I can group those rooms by floor, and I can group those floors by building. So I'm creating topologies and subtopologies. And I can do updates based on those topologies. So if I want to roll out an update to some devices, but I want to isolate which devices I'm rolling those out to based on those topologies. For example, I can just do an update to floor 1 because floor 1 is different than floor 2, and I don't want to do it to everything. I can do that, or I can do it to an individual room. I can also do security isolation based on some of these topologies and some of these groups. So I can permission group 1, or floor 1, different than I permission group 2. So now with the device management capabilities, I have update and grouping and security-based topologies and things like that that make it really interesting. So this means I can enroll devices, I can organize my devices, I can maintain them, I can decommission them, I can do all the things you want to do when you start thinking about, I've got more than one. When you've got one, it's really easy. When you have 100, it's harder. When you have 1,000, it's really hard. When you have 1,000,000, it's even harder. And it is not hard to have 1,000,000, quite frankly. In a building especially, it would not be hard. So if you think about how this works, we start with the device. And what is on the device itself? So on the device is primarily two things. One is the device management client library. So just like we saw the device client library for doing the messaging, we have a device management client library that sits on that device. And then your device code, whatever code you write, whatever function that thing performs. That's on the client side. Now on the service side, up in IoT Hub and IoT Suite, you have a representation of that thing. So you saw Cameron showed in IoT Hub where he could create a device. That was a software representation of the physical device. And that software representation of that device is just an object that's up there, and it maintains the last known state of that device and what it was doing. So you can always go check and say, what was the last known state of that device? And then we add all these device management APIs. So we have things like the registry manager. So I want to create a device, update a device, delete a device, all those things, all the CRUD operations around devices. We have grouping APIs. So how do you organize those devices? How do you add devices to groups? How do you remove devices from groups? How do you create those topologies and subtopologies? Querying APIs. So you can imagine if you want to search for devices that have a certain tag, that maybe have a certain type of device, or you say, I want to find all devices of this this type or this firmware or whatever it may be, and I want to see what their last known state was, whether it was enabled or disabled or something like that. All the non-application level stuff. And then job APIs, so you can do things like creating and monitoring and doing all the things you would do with devices. And then behind all of that is your application code, and you're talking from your application code through IoT Hub using those protocols, the lightweight machine-to-machine protocols over CoAP and TCP, to your device. So that's the scenario on how it works. And now it's a lot to digest in there. There's a lot for us to take in. So Cameron, once again, ladies and gentlemen, is going to show us how it works.
Yes.
Let me switch you over there.
Oh, sure. So what I'm going to show you here is, oh, by the way, the Azure IoT suite that we started at the beginning here has successfully, that's a lot of solutions that we've.
You created a lot of suites.
Yeah, I actually didn't do that. It did actually complete, and everything worked well, so that's all good news. Okay. Back to this. Okay, so what you see here is an Azure IoT suite that we have actually customized a little bit to show a device that's been disabled. And what we've done, and I'm going to show you in a second, we've added a button here that allows me to update the firmware of this particular device. This device is right here. It's an Intel Edison board. It's running Yocto Linux, and I'm going to update the firmware via a command coming from the Azure IoT suite. Let me show you how I can do that. So right now it is disabled. And it's disabled because that client library is essentially, it's turned off. It's not up. The agent is off. So what I'm doing is, here I am actually, I've got a serial connection to this Edison board here, and I'm going to run my little script to start the client. And what you'll see is it will connect, and it'll start to speak LWM to M to IoT Hub. And I'm going to spend about 30 minutes talking about each of these things here in about, yeah.
Can you start with the first octet?
No, I'm not going to talk about this. So this is native LWM to M back and forth to the hub. OK, the interesting thing that's going to happen here, though, if I refresh, this should now be enabled. There we go. OK, so it's running.
I'm just here for you. I'm here for you.
That's just super painful. OK, so here we have, this is that new button that I talked about, update firmware. Now, if you notice down here is the firmware version. And this is the thing I want to drive your attention to, because I want to update this firmware. OK? So its current firmware is weekly 159. OK? So now I want to do something really complicated and hit the update firmware button.
You love buttons.
Yes. And so there we go. And boom, you see the URL of new firmware, and it's pointing at this thing. So now here's what's going to happen. I'm not going to have you sit here and watch as we pull down a new firmware image. So what we did is we actually put the new firmware on this device in a zip file. And so what you see, it's just inflating that zip file that has the new firmware. Okay? Now, this is going to take a couple minutes, 3 or 4 or so, to reflash. And so while it does that, I want to actually go into detail on what you're seeing happening here to just drive this home. So what has just happened is I have initiated a device job. And what that means is, so my code, your code in the cloud you see on the far right there, that starts an update firmware job. All right? And that's representing your code. That thing turns around to Azure IoT Hub, and it started a job. The new device management code that we're putting into the hub has a concept of job orchestrations. Firmware updating being a standard orchestration that we want to be able to handle for you. Think of this way. I'm updating the firmware of this one device, right? Doug, though, showed you a picture of what could be a massive building with tons of devices in that building. From this one portal, you'll be able to say, I need to update building 54, floor 22, room 17, all the devices in there, go. Okay? So although I'm just focusing on this one device, this orchestration can occur over many devices. Okay? So keep that in mind as we go. Now, the other thing that I want to also really make sure everyone's super clear on, we're initiating the job firmware update. It's a job. Firmware update. Microsoft actually is not doing the firmware upgrade itself, okay? What we do is we send to the device, and this is also application defined. You guys send that parameter in terms of where to pull the firmware image, right? We send that to the device, and then it's your code that is responsible for pulling down that image and then doing something with it, right? Microsoft is not going to upgrade it's not actually going to perform the upgrade. We're going to let you guys brick your device. We're not going to do that for you, right?
We're just the messenger. We're just the messenger.
That probably came out wrong. So then your code then downloads the firmware, and you basically report back to the hub, and you say, look, I got the firmware, all right, and now I want you to monitor the state changes. Because if you notice over here on the right, can you switch?
Wrong computer.
Yeah, so real quick, switch back. So you notice over here on the right, that is communicating. It's basically, there's a pulse that's happening there in order to get progress. And it says, OK, it's updating, it's updating, it's updating. OK, you can back. Go back there. OK. Now, you've got another chance to hook in your code so that anytime during the job execution, you can go update some UI, like I just showed you. That's what this status of the job. That's a key piece of this, because you need to understand if the job is running, maybe you shouldn't start one, blah, 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 right? Then you actually apply the update. And this is where the actual flashing begins. That is currently running right now on this device. And so this is basically the monitor state changes tells the device management code, that is the Azure device management, hey, tell the application code, event the code to go and apply the update. And then your code then does the flash, okay? I hope this is, my fear is that this gets overly complicated, and I hope it's not. But now it's your code that actually does apply the update. And once that happens, once the update occurs, and once you've brought the device back up, you reconnect to Azure IoT Hub, and you initiate a monitor state change, and you basically say, look, we're done. The job is completed, right? So there's this pretty complicated handshake that happens, but most of that handshaking is done with the device management client API or client libraries on the device itself, with a couple little hooks that you can get in there and play as well, okay? I hope that's super clear.
So the gist of it is, the service will raise events that your code can respond to, and will act as a messenger or a transport for the packages that you need to move back and forth, but your code is always in charge. Your code is always doing what it needs to do.
And so there, I've got that last bit that said, hey, I'm done. You'll see this is now firmware update completed. The only thing that I have to do here is I don't have the auto restart, so I'm going to do the run DM client sh. And actually, I don't even need to do that. I forgot.
Nope.
Notice here, custom version, custom build Hytham. The firmware has been updated. And that little property there was actually sent from that device management library up to the hub. What is Hytham? He's the developer that wrote this code. So yay, Hytham.
Good job, Hytham.
OK. And that's it. And with a little bug here, I should just refresh this, and you'll see it's actually being represented there as well. And that's it. So that real complicated handshake that happens is actually a very well-defined, orchestrated handshake that we can then go and run that over thousands and thousands of devices. And firmware upgrade is just one. We're going to have a number of other jobs that come right out of the box, like a reset, restart, reconfigure, that sort of thing. OK?
All right. Excellent job, Cameron. Thank you.
Yep.
Ladies and gentlemen, Cameron Skinner.
Yeah.
I just like a little applause when I walk up. That's why I do it.
So painful.
All right. So that was one of the 4 things that we made announcements on that I promised you we'd tell you about. The other one is our new Azure IoT Gateway SDK, which is coming very soon. The reason this is important is, and I don't know that I can stress enough, the gateway pattern is a pervasive pattern in IoT. There are lots of use cases where you have an individual device, like the Edison-based device that Cameron was working with, talking directly to the cloud and doing what it does. But there are a large number of scenarios in which you will have multiple sensors and multiple devices that sort of aggregate together into a field gateway, a device out in the field that pulls all the data from those sensors together and either manages the communications for those one by one or aggregates them into some sort of complex message and sends that up. This you see, I mean, if you have, how many people here have like home automation systems and things like that? So a lot of people.
Cool.
The gateway systems you see there are common. You have light bulbs connected and you have a hub, like a Philips Hue thing. You have a hub hub, and all these light bulbs. Those are the slave devices. The hub is the gateway that enables all of those things to connect and share their state and their information with the cloud. We see this in cars, we see this in buildings, we see this in home automation, in factories, in manufacturing. It's hugely prevalent. So we want to support that scenario, and we're developing a gateway SDK specifically for that will enable the connectivity of lots of sensors through a single gateway. In some cases, it might be sensors that aren't capable of communicating to the cloud directly, but can talk to a gateway device. In some cases, maybe they speak a protocol that isn't supported by IoT hubs, so the gateway becomes a protocol adapter, especially where you have legacy systems in place where you're already doing some automation or some machine-to-machine communications, but you're not using one of the protocols that we support. The gateway becomes the protocol adapter for that. Gives you everything you need to sort of build a solution that works and works well. So the gateway SDK is coming soon. Be patient. It's going to be awesome. You're going to love it. Next, it's global availability. You want to talk a little bit about this?
Sure,
We saw this morning.
Yeah. So this is just a few new regions that the IoT Hub is going to be ready at. So actually, these are out there now. So Australia, Japan, Germany, and then our roadmap. Right. This is fairly self-evident, but I do want to just state that we've got 30 regions in Azure that Azure All Up has, and whenever you bring up a new service, you've got to kind of pick your battles and figure out which regions you can get into soonest. And some of the regions that are, like for instance in Germany, that have a safe harbor associated with it, they're a little bit more difficult, takes a little longer for us to get into because it's actually a third party that's dealing with the code for data privacy purposes. So we're rolling out and we're going to get out to all 30 regions as quickly as possible.
One of my favorite things of our announcements that we're doing this week is something that a lot of people here will get really excited about, which is the introduction of our Azure IoT Starter Kits. A guy on our team, Hector, has been working really hard on these to make these come to life, working with a bunch of different distributors and vendors to create kits that you can get, and they come with sensors and devices and things like that, and you can start working with them, and there's samples for all of the kits that would enable you to connect them right into Azure IoT hubs and start doing cool things. Just in this one hand, I have 3 of the different processors that are used in these kits. All these kits are a little bit different. And certainly you're not limited to these kits, but these are meant to make it easy for you to get started. Right here I have in my hand this little tiny red thing, and my point is this is very small. This is a Wi-Fi enabled development device that you can use. In fact, if you're not using this in prototyping, it gets a lot smaller than this and still gives you Wi-Fi connectivity. This is the SparkFun ThingDev. It's based on the ESP8266 processor, which is taking the IoT world by storm because it's small, it's super inexpensive, and it's Wi-Fi enabled. For a device like this, you would use the Arduino IDE, and we have SDK examples to use Arduino IDE to connect this device to Azure IoT Hub. So super cool to do that. The next device is very similar to that. This is one from Adafruit. This is the Feather Huzzah, which is also an ESP8266 chip, just from a different provider. They have different flash memory on them, so depending on what you do, the Huzzah has a little bit more flash memory than the ThingDev does, so you can get different kits for different things. These kits come not only with these processors, but also with sensors you can connect to them, and temperature and motion and stuff like that. We have another chip here, the Adafruit Feather, which is a bigger 32-bit SAMD chip. That will, again, those are all going to use the Arduino IDE and C code. One of my personal favorites that Cameron was working with in a slightly different form factor is the Intel Edison. This is a little tiny board. In fact, most of what you see here is not the Edison. Let me pop it off of here. This little thing is the Edison. This is a Wi-Fi enabled device that is capable of running Linux. So you saw it running Yocto Linux, which is the official image for this device. And then in the kit that you get, it comes with this Arduino compatible shield that you hook the device onto. And then there's another shield that pops on top of it that enables you to plug sensors right into it, so you don't have to do all the breadboarding and dealing with resistors and all that stuff. It comes with a whole bunch of sensors that just plug right in for super easy prototyping and working with, and it's a really fun device to work with. And then, of course, the Raspberry Pi 2. We have the kits for the Raspberry Pi 2 somewhere on that list. You can run Windows 10 on these devices, and you can build universal web apps or background apps in C# that run on these devices and connect right into Azure IoT Hub. So we have all of those kits now are available. If you go to the Azure IoT website, there'll be links there, and you can go buy them directly from the providers. And who has pieces of paper? Look, see, I told you it would spell IoT.
Yeah, that's exactly what it spells.
All right, so we have downstairs in the hub, who's been down to the hub? The little ask everybody. Fantastic. You all know where you'll find it. That's the important part. How many people saw the big pile of boxes of these devices down there? A bunch of you. How many came to this session just because of that? That's what I thought. Ooh. I know. All right, so here's the deal. We have a bunch of these down there. We didn't have enough for everybody in the room, so we handed out some colored pieces of paper sort of at random. And if you have a blue piece of paper, you can take that and redeem it for one of these devices to take home.